So here's the last table you're going to be looking at for critical values. This is the ChiSquare distribution, and this will be used for goodness of fit tests and tests for independence. And how the chi-square works, when we're calculating a test statistic, in effect what we're looking for our null hypothesis is either variables are independent, or in a goodness of fit that data fit a particular distribution. In order to reject that null hypothesis, what's going to end up happening is our observed values will be far away from our expected values, and so the chi-square test statistic, say that 5 times fast, the test statistic will be large. The differences between observed and expected will be large. Those get squared. So the bigger those differences, the larger the test statistic. And what we're looking for in terms of rejecting the null is a large test statistic. So if observed values are far from their expected value, it would seem as if our assumption of independence or of good fit were not good assumptions. So looking down here at the bottom of the page, we're looking basically at this this right tail. The right tail test. So one tail, the entire significance level typically we'll use 0.05 will be in the right tail. So in effect, down here in this tail would be large test statistics. So we'll be rejecting down here. How we find the value we're looking for, again, always a right-tailed test that we'll be using. So here are the values. 0.05 is one we'll typically use. And we'll go down this column until we get to the specified degrees of freedom that we're looking for. For the goodness of fit test, we'll take n minus 1, where n is the number of categories we're looking at. For example, if we're looking at the number of days of the week, there are 7 days in the week. If we're doing some goodness of fit test for that, the degrees of freedom would be 6, 7 minus 1. So a test, or a critical value of 12.592. We're looking at contingency tables, tests for independence. We find the degrees of freedom by taking the row variable and taking the number of categories minus 1, and then multiplied by the number of column variable categories minus 1. So for example, if we're looking at a 2 by 2 table where we have gender and smoking status, we'll have male, female for gender, we'll have smoking, non-smoking for smoking status. So there's 2 categories for each. So 2 minus 1 times 2 minus 1 is 1 times 1, which is, yes, 1. Good. So there'll be 1 degree of freedom, which would give us a test statistic of 3.841. In the course notes, we've looked at the gender in relation to political party affiliation. There we have a 2 by 3 table, 2 rows, 3 columns. So gender, 2 categories, political affiliation, 3 categories. So the degrees of freedom would be 2 minus 1 times 3 minus 1, or 1 times 2, or 2. And that value would be 5.991.